This is Pre-Calc 12, Chapter 7.4. We're going to look at Pythagorean identities. All of these identities are off the basic identity, x squared plus y squared equals 1 squared. So cos squared theta plus sine squared theta equals 1. From here, you will be able to prove more complicated identities. So let's start off with this divided by cos squared theta. So we have sine squared theta over cos squared theta plus cos squared theta over cos squared theta equals 1 over cos squared theta. This gives us tan squared theta plus 1 equals secant squared theta. From this one, we can rearrange this into sine squared theta equals 1 minus cos squared theta. And we can also get cos squared theta equals 1 minus sine squared theta. From this one, we can go here and get tan squared theta equals secant squared theta minus 1. We can also rearrange it to get secant squared theta minus tan squared theta equals 1. Okay, so let's take the same thing here, bring it down here, divide everything by sine squared theta. So we get sine squared theta over sine squared theta plus cos squared theta over sine squared theta equals 1 over sine squared theta. And this simplifies to 1 plus cotangent squared theta equals cosecant squared theta. And from here, we can get cotangent squared theta equals cosecant squared theta minus 1. And we can do cosecant squared theta minus cotangent squared theta equals 1. And with these new identities, we use the same strategies, but we have to look for more identities. Let's look at an example. 2 secant theta equals cos theta all over 1 minus sine theta plus cos theta all over 1 minus sine squared theta. We have NPVs. Sine theta cannot equal plus or minus 1. So theta cannot equal plus or minus pi over 2. The right-hand side looks more complicated, so let's work with that. We have cos theta over 1 minus sine theta plus cos theta over 1 plus sine theta. We need to look for a common denominator. This one needs 1 plus sine theta. This one needs 1 minus sine theta. So we have cos theta times 1 plus sine theta all over 1 minus sine squared theta. This is plus cos theta times 1 minus sine theta. Now we can expand this. We're missing a theta there. Cos theta plus sine theta cos theta plus cos theta minus sine theta cos theta. Here, we're using the identity. And we just substitute cos squared theta. We see that sine theta cos theta cancels with negative sine theta cos theta. And we're left with 2 cos theta over cos squared theta. Cancel out 1 cos theta, and we get 2 over cos theta. And we use the reciprocal, so we have 2 secant theta, and that equals the left-hand side, and quad error demonstratum. Let's look at the next example. We're going to use identities to solve. So we don't have any way to convert a cos theta into sine theta, but we do have a way to convert sine squared theta into cos theta. So we have 1 minus cos squared theta minus 3 cos theta equals 0. Now we substitute. Y is equal to cos theta. So we have 2 minus 2y minus 3y. So that's 2y squared equals 0. And we can factor this, minus 2y plus 1 and y plus 2. So we have 2 solutions. Y is equal to 1/2 and y is equal to negative 2. Substitute cos theta back in. There is no solution because it's not in the domain. Here we do have a solution, and we have a special ratio. Theta equals inverse cos of 1/2. So theta equals pi over 3. Again, we look at all students take calculus. Where is cosine positive? It's positive in quadrant 1 and 4. We already have our quadrant 1 answer. So quadrant 4 equals 2 pi minus pi over 3, and that's 5 pi over 3. Now we need to write our general solution. Since we're not given a domain, we're going to have an infinite number of solutions. We have pi over 3 plus 2 pi n. And we also have pi over 3 plus 2 pi n from the set of integers. To prove or solve quickly, we need to get used to recognizing the identities, and we want to quickly substitute. Here's a harder example. Prove 1 minus sine squared x minus 2 cos x all over cos squared x minus cos x minus 2 equals 1 over secant x. So what you want to notice is there's only one sine x. Everything else is in terms of cosine. So we want to replace this with a cosine identity. That's cos squared x minus 2 cos x all over cos squared x minus cos x minus 2 equals, well, we don't need the equals, we're only working with the left-hand side. So now we substitute with y equals cos x. So we have y squared minus 2y all over y squared minus y minus 2, and we factor. So we have y times y minus 2 and y minus 2 and y plus 1. We can cancel this out. We have y over y plus 1. This is cos x over cos x plus 1. And here we're substituting back up. It doesn't quite look like this, so let's divide everything by cos x. So cos x divided by cos x. And we have cos x divided by cos x plus 1 divided by cos x. So these go to 1. And now we have 1 over 1 plus 1 over cos x can be replaced by secant x. And that equals the right-hand side. And QED. One last example. We're given an interval. So that must mean we're solving rather than proving. I see a cos x, so we'll need to convert this into cos x. Cos x plus 1 equals 2 times 1 minus cos squared x. So we let y equal cos x, and we have y plus 1 equals 2 times 1 minus y squared. This is y plus 1 equals 2 minus 2y squared. Move everything to one side. We have y squared plus y minus 1 equals 0. Factor, we have 2y minus 1 and y plus 1. So we have y is equal to 1/2 and y is equal to negative 1. And we substitute back, so cos x equals negative 1 and cos x equals 1/2. Here we have one solution. Here we have two solutions. And since we're doing degrees, this is going to be 180 plus 360 n. So x equals 180 degrees. If we add 360 or subtract 360, we'll be outside of this domain. Here we have x is equals 60 degrees. Because this is a special ratio, we have cosine being positive, so we also have a solution in quadrant 4. So x is equal to minus 60 degrees as well. We add 360 and we subtract 360. So 360 is too big, and we subtract 360, that's too big. We subtract 360, that's too big. We add 360, that's also too big. So we only have three solutions. We have 180, 60, and negative 60. And that completes this lesson.